Hello, everybody. I am Víctor Rivilla, researcher at the Centro de Astrobiología in Madrid, Spain. In my seminar, I will talk about the limits of the chemical complexity that can be attained in the interstellar medium, and about its possible contribution for triggering prebiotic chemistry. As all of you know, one of the main challenges in the study of the origin of life is that we lack direct evidence of the conditions of the early Earth when the first organism appeared. In particular, we don't have any proof of the molecular material that form the building blocks of life. In this regard, prebiotic experiments in the laboratory have suggested that the RNA world, which is deemed the most plausible explanation for the origin of life, could have started from relatively simple molecular precursors, species with only a handful of atoms. And since our solar system was formed from a molecular cloud in the interstellar medium, it raises the question whether some of the basic ingredients of the life recipe had an interstellar origin, given that they could have been delivered towards the Earth's surface through meteoritic and cometary impacts. In other words, could the chemistry that occurs in space have a fundamental contribution to triggering prebiotic chemistry here on Earth or elsewhere in the galaxy? Well, to answer this question, we need first to know how rich is the chemistry that happens in the interstellar medium, in the molecular clouds where stars and planets form. Unfortunately, despite outer space is a very hostile environment, we know that it harbors a great variety of molecules. Nowadays, the improved sensitivity of current radio telescopes and the advance in laboratory molecular spectroscopy are indeed revolutionizing the detection of new molecules in space, with over 80 new species discovered only in the last 3 years. In my seminar, I will present the most recent results of our query of new species with astrobiological interest in space, combining ultra-sensitive unbiased observational spectral surveys and spectroscopic studies in the lab. In particular, I will show our findings towards the molecular cloud G+0693 located in the galactic center. This source has been revealed as a true astrochemical mine, since it has provided us the detection of 18 new molecular species in the last 5 years. Among them, we have the first glycine isomer detected in space, glycolamide, but also key precursors of RNA nucleotides, such as hydroxylamine or ethandiol, precursors of proteins, such as carbonic acids, of lipids, such as ethanolamine and propanol, and also new interstellar species with phosphorus, one of the key elements for life. So obviously, besides the detection of these possible molecular precursors of life, we also want to understand how they are synthesized in space, and also equally important, how they can elude destruction. So to achieve this ambitious goal, we combine the results of our sensitive astronomical observations with theoretical efforts using quantum chemical calculation and chemical models, whose outcome I will also present in the seminar. So please join the seminar to know more, and see you all soon.